Thank you, thank you. Hello. Yes, so I'm going to be talking about Kagent today. The title I chose for this talk is Rethinking the Open Source Agent Stack, but I'm still workshopping that one. So, all right. As Alexi said, my name is Eitan Yarmush. I'm a senior architect at Solo.io. Solo.io is an application networking company based out of Boston. And you say to yourself, what's an application networking company doing here? That's a great question. So let's get into that. There we go. All right, so before we talk about agents, let's start from the beginning. Who is Solo.io? Well, as I said, we're an application networking company, particularly focused on Kubernetes. So we've been around about 6 years, and we primarily focus on service mesh, gateway, so basically all things connectivity for modern day applications. So, as we, like everyone else, we saw the current trend in AI changing the market. This was about 2 years ago, and so we said to ourselves, okay, well, how can we use this new technology to benefit our customers and users? Right, so that was our first question, and it's worth noting the way, as I said, we're a networking company, so we view everything with a networking lens, right? When we tackle a problem, that's where we're going to start from. Now, that doesn't mean that's where we're going to end, but it just helps to frame where we're starting from. So with that in mind, when we started jumping into building these agents, we found that a few things were missing. So what were those things? Well, let's start with agents. Right, so when we started building agents, the first thing that we started to do was build them for our field team. So what does our field team do? Our field team essentially, right, is responsible for helping customers with their production deployments of our software, right? And as anyone who has worked with a network before knows, networks are extremely complicated. Yes, it's usually DNS, that's true, but how you get there is often a long and windy road. So we started building these agents for our field team to help them debug software in our customers' environments. And as we were doing that, we really figured out that we could break down any agent into three main parts. That is the system prompt, the LLM, and the tools. And obviously, there are more pieces surrounding that, data, etc. But I think that, at the end of the day, it's really these three things. There's the system prompt, or the instructions, the behavior. The LLM is the thing actually acting. And then there's the tools. And the tools are where you bring your own actions, your own data into the system. Okay, so if those are the three core pieces, right, what's the 90% use case of these agents? Let's be honest. It's you have Bob, or Bill, or whoever this guy is, right? He sends a user prompt into the agent, right? Or some machine sends a user prompt into the agent. That user prompt is appended to the instructions or the system prompt. That is then combined with a set of tools sent to the LLM, right? Those tools are executed, and then that output is appended again and again until you've finished whatever task that you've set out to do. Now, I'm not going to say that's the only use case, of course. There are many, many use cases, but we found that 90% of the time, this is what agents are doing. Okay, so let's talk about tools for a second. If, as I mentioned, this is really all that most agents are doing, okay, then what's the important part of the system? The important part is the tools, right? The tools are where you're going to derive all of your value from an agentic system. Okay? Tools are if the LLM is the brain, the tools are your hands. The tools are able to query data. The tools are able to save things. The tools are able to take actions. The tools are really able to do anything, right? So that's what makes this combination so potent. Okay, so again, I have some examples here. You could access GitHub, Docker, Slack, etc. Okay, so before we jump into more details, I do just want to talk quickly about MCP. Everyone here has probably heard the word before, but it stands for Model Context Protocol. And essentially, the Model Context Protocol is a way to expose tools to an agent, right? And it allows for discovery and execution of tools in a common way which makes them portable across agent frameworks, which is something that we'll talk about later. But since we're at an open source conference, I also think that open standards, right? Open source, I'm a huge believer in open source, but open source is founded really on open standards. So the more open standards that you have, the more growth in your open source community that you can have in the future. Awesome. So given what we've talked about, right, we said that the core, so we talked about the core loop, right? The core loop is just the system prompt, the tools, and the LLM. All right, so how do you scale that, right? So this is what I like to call the 7-layer cake, even though there's not 7 layers, and that might not even translate into different languages and cultures. But anyway, what you really have is essentially a tiered model of your framework, of an agentic system. Okay, so at the top level, you have your framework, all right? And the framework is, it can be LangChain, it can be AutoGen, it can be AG2, it can be Llama Index, it can be CrewAI, it can be anything, right? Beneath that, you have your agents, okay? And your agents are communicating with each other, they're communicating with tools, right? So they are at the second level. They are the things that are, so you have the framework, which is managing the agents and managing the workflows and the communication between agents. And then you have the agents, which are communicating with the tools. Awesome. So putting it all together, what exactly is Kagent? So far, all I've done is talk about agents in general. So what is Kagent? Well, again, I mentioned at the beginning this 90% use case. So what we decided to do, given our lifeblood in Kubernetes, is we said, okay, how can we bring our Kubernetes experience and our newfound agentic experience to the community? And our answer was Kagent. So essentially, what Kagent is it's an agentic framework built on and for Kubernetes. Now, it can handle any task. I will show that in a few minutes in the demo, but it's primarily built on and for Kubernetes. So what a lot of times I've found in talking to users, talking to people, just experimenting on my own, is that it's really easy with the existing frameworks to build an agent, right? You write some Python code, boom, wow, I've done this thing. But it's really not clear how you put that thing into production, right? It's not clear where do you run that thing, right? How does this thing work? What's the long-term strategy for this agent? How do I expose it to my users, et cetera, et cetera? So that's where Kagent comes in. It has an opinionated approach, and it runs really easily right on top of Kubernetes. Okay, so I'm just going to talk quickly about the architecture, but I'm not going to dwell too much on it. But essentially, for those who are familiar with Kubernetes, it's a declarative system, right? That's one of the amazing things about it. Essentially, it is a declarative config, okay? So you create, your deployment, and all of a sudden your thing is running, right? So in our case, we said, wait, can we do that with agents? And the answer is, heck yeah, you can. So what you do in our case is, again, remember, we're optimizing for the 90% use case where all your agent does is, where all the business value is in the tools, right? So in our case, the agents are actually just CRDs. So it's just text, right? It's a declarative config. So you create agents simply by creating their config. And I'm going to show this in a minute. So once you've created the CRDs, right, we have a Go controller, which is reading those CRDs and then putting them into AutoGen. And then the user can interact with the AutoGen agents. Now, AutoGen is completely abstracted from the user. Now, I do want to talk about it for a second because I think it's an important implementation detail. We are built completely on top of AutoGen. And I think that's one of the main things that separates us from traditional, I can't believe I'm saying traditional agentic frameworks because it's been about, there's so many now. We're not trying to build another one. We're not trying to be yet another core framework because there are so many and there will be so many more. So instead, what we decided is let's build on top of something that already has a ton of features. It has corporate backing with Microsoft, right? It's the sort of thing that we are confident in, and we found that it has everything that we need. Not to mention that AutoGen, under the hood, is actually declarative. which I don't have time to fully speak about why I think that's an amazing approach, but I'm happy to answer questions about that after the talk. So anyway, so once it's been stored in AutoGen, then the user can interact with it via either a CLI, the UI, or we have a REST API. And as of a couple days ago, you can also use the A2A protocol. Cool. So here's an example. I'm going to show a demo in a second. But again, the idea here is that this is a whole agent, right? There's no code. There's nothing. All you do is create this YAML that's type agent, right? You have a system message. You point to a model, right? That's our LLM. So you have our system prompt, we have our LLM, and we have our tools. That's it, right? And so the tool server here, right, is a pointer to an MCP server, which is running in my cluster. Okay, so again, it's literally just two pieces, and what we did is we built it from the ground up with MCP support because we realized that one, there's going to be the community has already built hundreds of these things. So if you need to plug into your OpenSearch cluster, or you want to use your Elasticsearch database, or whatever it is, there's an MCP server for that. So all you need to do is run that thing in Kubernetes, and you're off to the races. Or you can run it wherever, but we find that easier to run it in Kubernetes. And your infra team will be way happier with you too. All right, so with that, I'm going to do a quick demo. All right, let's see how this goes. Okay, 1 second. I asked for a table. I was not given. No, I'm just kidding. You were amazing. Oh, sure. Alrighty, so let me just open up. So we also have a UI, so I'm going to open that up really quick. I think, yes, okay. All right, 1 second. Alrighty. All right, cool. So this is Kagent. Let me make it bigger. Okay, so this is Kagent. Again, this is a nice UI built on top of the core system, which is just the CRDs, as I mentioned. But I'm going to show through this. All right, so as I said, this is a framework built on top of and for Kubernetes. So let's just quickly start interacting with our cluster, right? So let's see what we have running here. So I'm going to chat with my Kubernetes agent. I'm going to ask it, hey, what's running in the cluster? Okay, now it's going to go ahead and tell me. Now, note that I didn't have to actually create this agent, so we have a few workloads. So we have a few different agents that we pre-bake into the system so that you can get up and running, but these are not meant to like run in production or anything. They're just a way to quickly get up and started with the system. So as you can see here, I asked it what workloads are running, and it told me that, and it just gave me a summary. So now I want to drill down on this agent gateway pod. I'm curious what that is. Typing with one hand is very difficult. Okay. All right. So I would like more detail, and I will say that one of the interesting things about having it like this is that oftentimes we found that the most important part of the agent, aside from the tools, is the system prompt. Right, and so as you can see here, I've actually had to send multiple communications to it because the system prompt is not optimized, right? It's not doing exactly what I want it to. So now, after we're done, I'm going to go back and I can actually just go in and edit the system prompt. Okay, so it gave me a bunch of information, how many are running, et cetera, and it says I have this config JSON that's configuring it. So I'm curious, all right, what's in that config net? That's okay. So now, and again, the cool thing here is just that it's able to say, all right, I'm going to go in, I'm going to see what's going on, and then you can continue to dive in without having to understand the system or understand kubectl or any of these other Kubernetes native things. So it went ahead and did that. It tells me that there's this gateway and some config. All right. So now that we've used the built-in one, let's actually create one. So as I said, this thing was built on and for Kubernetes, but the reality is that it can actually work with anything. All right. So the first thing I'm going to do is I'm going to add a tool server. So a tool server is just a way, as I said, to interact with any MCP tools. Okay, so the tool server that I'm going to add, I actually have a tool server running locally, which can connect to GitHub. I didn't show that in the previous conversation because it has a private key in there. But anyway, so I'm going to show, so we're going to connect to that. So what I'm going to do is I'm going to add a tool server with a URL. We're going to call it GitHub. And it's going to be, cool. All right, I've gone ahead and added that. And it's going to take about 5 seconds to load the tools. So what's happening in the background right now is it's gone ahead and basically actuated this resource into the cluster. And then now the controller is going to go and it's going to ask the server for all the tools. And so if we just do a quick refresh, we'll see that all of the tools from our GitHub server are now here. So now that we have all of our GitHub tools, right, let's go ahead and create an agent to use those tools. Sorry, thanks. Okay, so it just needs a quick description, which this is really for agents that are communicating with each other, which we don't need right now. So I'll just put this here, but then I'll say, okay, you are an agent who helps users communicate with GitHub. You have tools for this purpose. Always be kind. Okay? So now that I've done that, I can actually just go ahead and add all of our tools. So let's go ahead and look at our GitHub tools. So what sorts of things do we want to do? Well, I don't know that we want to take any actions right now. That seems pretty dangerous. So instead, let's say, okay, we're going to be able to get issues, get pull requests. We're going to list, we don't need to list commits actually. We're going to list issues, we're going to list pull requests. We are going to search repositories and search users. Awesome. Okay, so now that we have our instructions, our name, and our tools, boom, done. And we have our model. So that's it. That's the whole agent. And so, and again, you could do this via YAML. This is just an easier experience, but the whole point is you're just not writing any code. So now, I'm going to go to my GitHub agent. I'm going to say, okay, can you list all of the repos in the all right. So I want to find out more about some of the repositories in the Kagent dev organization and some more info about them. So immediately it went off and used one of its tools. It says, okay, these are the repos. All right, well, I'm not super interested in the last three, but I do want to know what the open pull requests are in Kagent. So let's go ahead and ask. Okay, so it's going to go off and think, and it's going to say, all right, well, there are currently 5 open, so that's pretty nice. All right, so let's see what they are. Well, these don't seem super interesting, but I'm actually curious about the author of this PR. So let's see if we can get more information about this user. So now it's going to go off and it's going to say, okay, I'm going to search for GitHub users, and it found the profile, blah, blah, blah. Now, this is one of the funny things about trying to demo agents. the last time I did this, it popped up this user's profile picture, which was super funny because it was just a magic card. But of course, it decided not to do that this time because, you know, our technical overlords are not nice to us. So I'll just, here, let's see. What's that? All right, let's see if it pops up. There we go, and there's magic card. Okay, so, all right, so with that in mind, we're gonna jump back into the talk. But the main thing that I wanted to show with that demo is just that, again, the 90% use case here of people trying to use these agents is this loop. And we're constantly adding more use cases as well. But in terms of doing the core workflows, this worked for us for almost all of them. And it made iteration incredibly easy because now you don't need to push code or anything like that. Everything is picked up instantaneously by the controller and you can immediately test it. And so you can also version control it just like any of your other apps, right? So you can have Git repos to version control your agents as if they were applications, even though, again, just YAML. Okay, cool. So I've showed you Kagent. I've talked about our layer cake. So let's just take this a step further, okay? If this is the 7-layer cake of a framework or Kagent, right, can we do better? I think we can, right? It's actually, once you think about something like MCP, right, the actual layer cake of the framework is tiny. The only thing actually in the framework now, right, are the agents. That's the only thing, right? So what does that mean for the framework, right? What does that mean for the future of frameworks? So, and the other thing that I want to mention here is that if now all the tools, right, at the beginning when we made agents, all the tools were sort of functions, right, in the actual program. But if all the tools are moving out, right, there are positives to this, obviously, like you can bring tons of tools in, you can use community tools, etc. But now you have a security problem, right? All of a sudden, you have a ton of network traffic. All of a sudden, you have a ton of calls going over the network that you didn't have to worry about previously. So now, how have we solved this in the past, right? This may seem novel, but the reality is this is just a typical gateway use case, right? The reality is that what you want, like, and again, speaking here less about, I think when I say this, I'm speaking less about the at-home Claude user, right? The person who is building an agent to manage their own machine, right? To perform their own workflows. I'm really speaking about sort of businesses or larger users where they want to monitor their tool usage, right? They want to make sure that only certain users are allowed to use and see certain tools, right? Apply traditional network layer controls on top of what is now just another network problem, right? So at Solo, we realized that this is immediately going to be a problem. And so what we did was we created an agent gateway. Now, agent gateway, I'll speak about it in a minute, but essentially it's a purpose-built Rust proxy specifically to handle AI-related traffic flows, and I'll talk about why that's necessary in a minute. So again, let's take this up a layer, right? We said, or I said, we, the royal we, me, I claimed that now, right, all of our tools are just MCP calls, okay? But I'm gonna be honest, I've spoken to a lot of organizations now about how they're using agents, and not a single one has said that they're using one framework, okay? Not a single one. And I'm even talking about small orgs with like engineering teams of 10 people, still somehow end up with multiple frameworks. So we've discussed A2A across this conference multiple times, but I think it's worth talking about for a minute what it is and why it's different than MCP, okay? So MCP is really purpose-built for static resources, okay? Now, Google came out with A2A pretty recently because they know this problem, right? They understand that users are gonna have to have a compatibility layer between their agents. And having that as an open standard is going to benefit everyone. Everyone except the frameworks. Now, the thing is, personally, I'm more interested in there being an open standard because it means that people can more easily, again, market their own agents. They can easily expose their agents across their organization, right? And again, now that it's on the network, boom, you can apply the same network level logic that you've been applying the whole time. Because guess what? This is just HTTP traffic, okay? It has some special bells and whistles, and it has some special policies because it's all over server-sent events. But at the end of the day, this is the same pattern. So, again, this is really how we see this space playing forward. Now, it's for that reason that what I showed you today, right? What I showed you today is Kagent acting as this. But no, Kagent can actually bring in agents with A2A, right? So you can actually manage workflows and conversations with multiple agents across multiple frameworks, assuming that they implement this open standard, which we believe is going to be there will be an open standard here, and it seems, right now at least, things obviously move quickly, that this will probably be the one. And so you can actually manage the conversations and workflows across multiple without having to, that's it. And so you don't have to pick a framework, because again, they do different things, and from what I've seen, nobody is actually picking a single one. And so rather than trying to force people into picking one, right, let's meet people where they are, right, and let's have a conversation about it, and let's actually deal with that problem. So I said I would speak briefly about the agent gateway. Well, yeah, so I said I'd speak briefly about the agent gateway. It's a new gateway that we're building at Solo from the ground up, specifically built for the AI era of traffic. We looked around. We've been huge contributors to Envoy proxy. For anyone who knows about Envoy, huge believers in Envoy. But what we found is that Envoy is actually not super good at some of the use cases here without relying on some pretty difficult changes and external processing mechanisms. And so what we decided is, okay, let's build a new thing. We're going to build it in Rust. The MCP and A2A protocols are going to be first-class citizens. It's going to be AI-centric security and observability, and it's going to be totally open source. And we would love to build it with all of you. So I think before I wrap up, the one thing I want to say, and that I haven't really heard a lot of at this conference, which is surprising to me, is yes, everything is open source, obviously, but we would also love for you to come and contribute, right? I think that there's this interesting thing of like, we're all here building open source, we're all talking about open source, but the only way that works is if we all get involved. And so I'd say that I would love if everyone here would check it out and contribute to either Kagent or Agent Gateway, if either of those fit any of your use cases. Yeah, that's it. Thank you very much.